friends, this is Harsha. I am welcoming all of you in Academic Knowledge Institute. So today we are going to start the topic that is organic chemistry. This is the chapter number 8 in 10th standard ICSE. And today we are going to start the topic that is isomerism. First, we are going to see that is isomerism of organic compounds. What is isomers? What is isomerism? We will see that. The compounds who are having same molecular formula but different structural formula, that is known as isomers, and that phenomenon is known as isomerism. Getting? Okay. The next thing is that how these isomers are changing and how these isomers are forming. So as the number of carbon atoms is increasing, the isomers are also increasing. Next, we are going to see that is the types of isomers. There are so many types of isomers, like chain isomers, then position isomers, then functional isomers, then metamerism, tautomerism, and stereoisomerism. So let's see that one by one. What is chain isomers? Difference in arrangement of a carbon atoms. Like they are the same number of carbon atoms are present in both the compounds, but their arrangement is different. Then here the position. Like the position of a functional group is different. Here we can say the position of a single bond, double bond, or triple bond is different. So that is known as position isomer. Functional isomer is like where the functional group are different. And then stereoisomerism. It's a geometrical isomerism where the after the double bonds, like which compound is attached on which side, that does matter. Now we are going to see what is metamerism and tautomerism. Both metamerism and tautomerism are the structural isomers. What is structural isomers? Structural isomers are the those who are having the same molecular formula but their atoms are connected in a different orders. What is metamerism? It is a type of a structural isomers where different alkyl groups are attached to the same functional group. Like the functional group is same. If we are talking about the ether, then there will be ether group only. Ether as a functional group only. If we are talking about aldehyde, then aldehyde will be the functional group only. But they are attached to the same functional group, but their alkyl groups are different. If we are talking like here, I have taken the example that is the diethyl ether. So if we calculate this, so there are how many carbon atoms are there? 1, 2, 3, 4. 4 carbon atoms. There are how many hydrogen atoms are there? 3 plus 2, 5. 5 plus 2, 7. 7 plus 3. That is 10. Getting? That means here there are 4 carbon atoms, then 10 hydrogen atoms and 1 oxygen. Here, how many carbon atoms are there? 1, 2, 3, 4. These are again the 4 carbon atoms. 3 plus 2, 5. 5 plus 2, 7. 7 plus 3. That is 10. So this is 10 and then this is oxygen is single. Both are having the same functional group. Here is also the ether. Here is also the ether. But the alkyl groups attached to them is different. Here this is the ethyl. This is also ethyl. Here this is methyl group and this is the propyl group. Right? So this is the difference between the metamerism. They are having different alkyl groups are attached to the same functional group. Now we will see tautomerism. What is tautomerism? It is a dynamic equilibrium between two compounds with same molecular formula. So the first example we will take here, that is the ketoenol tautomerism. In the ketoenol tautomerism you will get exactly what is the tautomerism, you will get exactly that. The first thing is here, this is the keto form of acetone and this is the inner form of acetone. Then here you will get what exactly is happening. So here, see this alpha hydrogen of this carbon is converted into the oxygen here. How this keto form is transferred into the inner form? Like this, alpha hydrogen atom of this keto form is converted by enol by transferring this alpha hydrogen into oxygen. Getting? लाइक मैं आपको सिंपल वर्ड्स में बताती हूँ कि इसका जो हाइड्रोजन एटम है यहाँ का, ठीक है, ये इस ऑक्सीजन पे ट्रांसफर होता है. इसका जो डबल बॉन्ड होता है सिग्मा बॉन्ड एंड पाई बॉन्ड, सो उसमें जो पाई बॉन्ड होता है वो ब्रेक होके वो यहाँ से ब्रेक होके वो यहाँ पे अटैच होता है. सिंपल वर्ड. नाउ वी विल सी द एग्जांपल्स ऑफ आइसोमर्स. हियर आई हैव ड्रॉन द चेन आइसोमर्स. These are all from the alkane family. So the first we will start with the butane. You can see these isomers from propane also, but here I have drawn from the butane. This is the formula of a butane is that is C4H10. Here, this is the N-butane. This is CH3, CH2, CH2, CH3. So you can calculate the how many numbers of carbon atoms are here and how many numbers of hydrogen atom here. See these 1, 2, 3, 4. 4 carbons are here. Then 10 hydrogen should be there. 3 plus 2, 5. 5 plus 2, 7. 7 plus 3, 10. So 10 hydrogens are here. In isobutane, see the carbons are 4 only. The number of carbon atoms are 4 only. Just even the number of hydrogen atoms are also same. You can calculate this 3 plus 3 6, 6 plus 3 9, 9 plus 1 10. So 10 hydrogens are here. Just the arrangement of carbon atom is changed. Here this is all in a straight chain. Here this is the branched. So that's why this is isobutane. Okay. Then pentane. What is the formula of pentane? That is C5H12. You can check here. This is the N-pentane. 1, 2, 3, 4, 5. 5 carbons are here. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 3, 12. So there are the 12 hydrogen atoms. This in straight chain. This is branched and this is also in branched. But here only these carbon atoms are having only attached with these, and here these carbon atoms are attached this carbon atom also and this carbon atom also. This is the CH3, CH, CH3, CH2, CH3. Okay? Here why there is no hydrogen atom are here with this carbon? Because the carbons are having the valency of a 4 and this carbon are already fulfilled all the 4 valencies. Because here this carbon is attached to all the 4 carbon atom. So that's why here we don't have any hydrogen atom. Okay. And this is known as neopentane. Now we will see that is the examples of isomers, that is chain and position isomers. These all are from the alkene family. Here this is 1-butene. How many carbons are here? There are the 4 carbons are here and 8 hydrogens are here. The same thing is here also. Here also how many carbons are here? 1, 2, 3, 4. So this is the 4 carbon and 8 hydrogens. But this is the chain isomers. This is like straight chain and this is the branch chain here. Here this methyl group is in branched. So that's why this is known as chain isomerism. Getting? Okay. This is 1-butene. This is 2-methyl propene. Then here this is 1-butene. Here double bond is on first carbon. So that's why this is the 1-butene. And here this is the 2-butene. Why? Because this double bond is attached on the second carbon. So that's why this is the 2-butene. So here both the groups are same. Like here also is butene, here also is butene. But just the position of this double bond is different. So that's why this is the position isomers. And then this is the see, this is also the butene. This is also the 2-butene. This is also the 2-butene. But just the difference between this is this we have drawn in a geometrical form. So here this CH3 group and this CH3 groups are on one side only. So that's why this is known as cis-butene, cis-2-butene. But here the methyl group is present on a trans side. So that's why this isomers is known as cis-2-butene and this is known as trans-2-butene. This is the example of a geometrical isomerism and we can say that is the stereoisomers. Now we will see the examples of isomers, that is the position isomers. These all are from the alkyne family. Here this is the 1-butene. In alkyne family we all know that here this is the triple bond. So this triple bond is attached to the first carbon. So that's why this is the 1-butene. And here these triple bonds are attached to the second carbon. So that's why this is the 2-butene. But there is only the difference between the position of this triple bond position. So that's why this is known as the position isomers. Here if you check how many carbons are present. So these are the 4 carbons like 1, 2, 3, 4. And how many hydrogens are here? 3 plus 2, 5, 5 plus 1, 6. So 4 carbon atoms and 6 hydrogen atoms. So same is here also. And here this is 1-pentane. Here if we check, so this triple bond is present on a first carbon. So that's why we call it as a 1-pentane. Here this triple bond is present on the second carbon atom. So that's why this is known as the 2-pentane. Getting? If you check the how many carbons atom are present, so these are the 5 carbon atoms are present here, and how many hydrogen atoms are present here. 3 plus 2 5, 5 plus 2 7, 7 plus 1, that is 8. So 5 carbon atoms and 8 hydrogen atoms. So same thing is here also. So this is known as the position isomers. Alkynes are mainly showing the position isomers only. I hope आपको आज का ये वीडियो बहुत अच्छा लगा होगा, और आपको ये वीडियो कैसा लगा ये मुझे कमेंट बॉक्स में लिख के ज़रूर बताइए। तब तक हंसते रहिए, खुश रहिए और एकेडमिक नॉलेज इंस्टीट्यूट को देखते रहिए। थैंक यू सो मच।